So, hello guys, welcome to our Backbencher Studies channel. Today, we are going to learn representation of a system. In the last class, we have learned that how a closed loop system can be more accurate. We also saw this example in which how it would take an advantage based on uh, closed loop system, that is output continue being continuously measured. So how it will improve the accuracy and how it is less prone to disturbances we have seen. So then we have representation of systems. So we can represent a system based on differential equation set of differential uh, equations or block diagram we can, and signal flow graph and state equations. So these are the four different kinds where we actually represent a system. So first let us see how a system can be represented in differential equations. So we have the system output defined in terms of weighted summation of differential of input. So if we consider an example, consider a simple RC circuit with input voltage being fed in these two terminals and output voltage which is being taken across this capacitor. So we have what we call as the KVL. So if we apply KVL in this input loop, we have Vn of V. Vn is equal to, let us say, the current through this loop be IC, then we have IC into R, which is the voltage across this resistor, plus this output voltage, which is being measured across this capacitor. So we already know that this current which is flowing actually through the capacitor is nothing but the capacitance into rate of change of this output voltage. So if we substitute this IC, we have this kind of equation which is nothing but the KVL equation and this current through this capacitor equations. So if we apply Laplace transform on both sides, we get Bn of s, which is the previous time domain equation, is now converted into Laplace domain, and we have this the time differential over here into this s functionality, and we have the transfer function, which is nothing but the output ratio of Laplace transform of output to the Laplace transform of input. We have this kind of Laplace transform, and we have this kind of transfer function we have. So this is how we represent a system with differential equations. So we have this differential equation. Based on these differential equations, we have this transfer function, and this is how we achieve at a differential equation representation. So in the next class, we will be discussing block diagram approach, in which how to, well, we already discussed how to simplify block diagram and simplify block diagram rules. So see you in the next class, guys. So in the next class, we will be discussing block diagram approach. Thank you for listening. Thank you, guys.